Hello everybody, thank you for joining my session. By the way, this is my first session on any shows, so excuse me if I don't do it very well, but today I will try to explain and to show you how we created a unified communications solution based on Asterisk completely and made exclusively to work with Asterisk. And also for the chat part we use XMPP protocol. I will just mention who we are as a company and what we do very shortly, and then we will talk about our unified communications platform that we created, how it works and what are the main features. I will also try to explain the problem, how we solve this problem of syncing with real-time systems, so like Asterisk. I will mention our abstraction layer that we created for end-user applications, and also I will talk about multi-tenancy, how we solve that, and at the end of the presentation I will show you a small comparison with Asterisk Manager interface. So our company started in 2004, and the idea was to create a user interface for Asterisk. And since then we have actually diverged into many directions, and we have created several products around Asterisk. One of them is Serverware, which is the virtualization platform based on LXC technology. Then there is PBXware, which is then obviously installed within this Serverware in a very nice user interface and simple to use. Then there is this customer portal login for billing and invoices, and end user application called Glowcom, which is a kind of Skype for business solution for mobile and desktop applications. Our customers include service providers, call centers, government, and small to medium businesses. So now just a short introduction into the product, so that you can visually see more or less what we created. This is not real app, but just
Outlook or Google Contacts and coworkers all in one place. Drag and drop to make calls from your list of contacts directly from your web browser or Microsoft Outlook. Calls can be made straight from your PC using any IP handset or mobile device. When receiving a call, Glowcom will ring and the caller information will be displayed on your screen. If the caller is in your CRM system, it will instantly display the caller's information. Answer a call with voice or video, merge calls, transfer the call to a colleague, or send it to voicemail. Instant message with colleagues, send faxes or SMS. Organize group instant messaging and share files. Need to speak with several people at once? Drag and drop or schedule a conference call. Use a dedicated conference room. Add and remove coworkers from conferences, or add any number to a conference at any time. To start a dynamic conference, just drag a contact into an existing call. Coming soon, a screen sharing feature in Glowcom Mobile for iOS and Android. For more information, contact Bicom Systems today.
Later on we will be part of Dangerous demo, so we will actually be showing all of these features live. Okay, so before we start, I would like to ask you a question. How many of you have ever been working with Asterisk Manager, doing something like this? Okay. So started with Manager 10 years ago. I tried to create a Outlook integration application, and since then I learned lots of things and I faced lots of difficulties. So last year in the summer I realized that I need to create something better of that. So that is why I created this UC platform, which is its main purpose is to provide a high-level API for end-user applications. So many times during these years, customers come to me and say, do you have some API, does your product have some API so that we can integrate when the call comes in to pop up the screen and things like that? And I always have to refuse them because obviously Manager is not that easy to use. It's not, so to say, user-oriented, call-oriented. I like to say that Manager is just kind of a logger, but instead of to the file, it is logging it to the network, to the socket. And you cannot really, it's tons of events, such a complex service, and for one single call you get like tens of all different kinds of events, local channels, and all that stuff. And I wanted to create something simple, because if you think about it, when a person gets a call, in the background maybe there are 10 channels, local channels, then real SIP devices are ringing, because we obviously can have multiple SIP devices today. So why do I have to receive 20 events or 50? Why can't I just receive an event that will abstract all the behind-the-scenes stuff into a simple event and tell the end-user application that the call just started? So simple as that. So that's how I created this UC platform, and as you can see, these end-user apps interact with that using our control and signaling API, high-level API, and then this gateway in turn talks to Manager, and the voice path SIP or EX technology doesn't really matter. So behind the scenes it can be a SIP, an EX, or whichever protocol, and RTP, but everything will work transparently for these apps here. And I will now just mention a couple of features. So main one is that it provides high-level API, as I just mentioned. We are multi-tenant compatible, so that's also one of the obstacles with Asterisk itself, missing domains. Then we are compatible with latest Asterisk 13. The transport is secure. We provide WebSocket transport as well for web apps. And talking about WebSockets, now imagine an application, web application, how to implement something in web that interacts with Asterisk in real time. We cannot connect to Manager, obviously. And even if we could, we imagine an app that gets hundreds of events, and seeing events and calls from all people in the company and from other tenants, let's say, and all that stuff. Why? One doesn't need that. That application, when the user logs into the system, should only get the actual calls for him, unless, as we will see later, we want to provide some complex application features like we also created, but in reality it should be very simple. And we created it. This application is multi-threaded, So works very fast, and it has a very, very small network footprint. So now I will mention 4 problems. During these 10 years, I realized that manager is not user and call oriented. That's one big obstacle. So if I log into manager, a logical thing would be to get only my calls. I'm not interested into entire system, what's going on with, is my friend talking, is the local channel being created behind the scenes, all those tons of events. I don't want that. I want something simple. So Asterisk Manager is not prepared for that. The Asterisk is missing multi-domain support. So as I said, if other tenant is talking, I should not know that. There is a lack of taking the snapshot of the system, of the resources, in an atomic way. By that I mean, when you ask for a list of channels through manager, let's say, you will get them in because it will internally lock channels, resources, it will go to the list and will return it back to the client. In the next step, we would ask for the bridges, let's say, to see what are the bridges in the Asterisk. It will return us, but in the meantime, all different kinds of things happened. The channels that we just got a second ago are now maybe have been hanged up, have entered into some other bridge or whatever. So there is no anatomic operation that would say, give me a list of all channels, bridges, conferences, queues, agents. So give me the system snapshot. There is no such thing, which makes it really hard to do this initial step, because we know that manager is event-based system. So, but the initial step is always to get synced with the system. Afterwards, we do this incremental update. So this atomic system snapshot is a requirement, but manager is missing. And we have noticed that with many clients, manager seems to be, and Asterisk seems to be a little bit slow. So there is a performance impact on highly busy systems. So I will now show, this is the startup sync. We want to avoid doing this as much as possible. So that's why this UC gateway, PBXware UC gateway, only asks for this when we start our solution. So because of the lack of the system snapshots, as I said, we really try to just ask when on the startup of the application. And we forget about asking Asterisk anything else while our solution is running. So when we give a customer our product, he starts it. On the startup, we ask for these resources, obviously, of the Asterisk, and we never ever again ask Asterisk anything, because it's now, we then do incremental update using the events. And cache all that information in the memory, and then provide these atomic snapshots, virtualization API, and everything to the end user applications. So as you can see, every aspect of Asterisk, as I just said, is really reported back through manager. And I mean, that's a good thing, obviously. We can know literally anything that's going on in Asterisk. But end users, apps, don't want so much information. So that is why we created this in-memory caching of all the information and then provide a very simple API for the end user apps. We also use memcached in-memory database because sometimes we want to consume this information from within our user interface for monitoring stuff. So let me explain a little bit about our protocol. It's JSON based. We choose JSON because it's plain text. It's easier for tracking and debugging. It has same principle like manager. Users apps send actions, they get response, and there's event, all different kinds of events. So when the end user application connects, this is the flow of the things. It needs to start the TLS. After the handshake authorize, based on that authorization, this is an important step. When I authorize to the system, system knows who I am, which extension I am, and sends me only my calls. It filters out anything else because I really don't want. Why do I want other events? So that's the first thing that is different from manager. And then the next step is to atomically take this system snapshot. So when I press login in the application, I should sync with the system in an atomic way, and then afterwards use event-based system. So how we implemented this atomicity? We use this first in, first out, like some kind of event loop, which only one event is processed at a time. But when we get a user application requesting the state of the resources in the system, we stop this. We stop this processing thread and give the client what he wants. So the current state. Then afterwards, events will be sent and a client can update his own user interface or whatever. So that's the only way to make sure that client at the moment of the request really gets what is there at that specific moment in time, and afterwards send him changes, so to say, incrementally. So let's now talk a little bit about how we abstracted everything. As you can see in this simple example, two persons are talking. John Doe is calling to Bob. Using, let's say, an originate command from Asterisk. So click to dial software today works in that principle. User clicks on the desktop something, his phone rings. When he picks up the phone, call is made. So that's why here John Doe has his two devices ringing. Why second if he's making a call out? Because that's the way it works. When you say call, Asterisk will ring all your devices. You can have 10 of them, but you choose the one you want. And then in between, all different kind of local channels can exist. Bob, on the Bob side, his three devices, let's say, are ringing. So what we created this call here. And this call actually is sent in the events. To John Doe, it would just say, your call started, it's an outbound call, you are calling Bob. That's it. When Bob answers, he will get an event that will say, your call with this ID has been answered. If they later convert this call into a dynamic conference, let's say he will get an event that will say, your call became part of a conference. So simple as that. He and user apps actually don't know anything about the channels behind the scenes, which can be tons of them. So this is how our call signaling in our platform works. Let's not confuse this signaling with the SIP, of course. SIP signaling is one thing, EX, RTP, that's voice path, as we just said. And then we have our own abstraction and signaling events. And simple as this. So call started, answered, updated, finished, or if the call recording of that call changed, because I wanted to make sure that end user apps always know if the call is being recorded, not just on their side. Maybe somebody joins into the conference who has call recording option on, so all other participants will actually be informed of that. And then using a virtual call ID, each of these events will provide this virtual call ID that they later on use to control that call, to hang up, transfer, do attended transfer, start recording on that call, or maybe even add people into the call. Why not? A simple API that will say, add somebody into my call. And during the initial snapshot, of course, he will get all his calls that are going. For the call control, as I explained already, as you can see, this side has a very straightforward API, which then is converted by this to control actual channels, hang up them, or make some, originate some call wherever, transfer channels. So behind the scenes, this translates everything to the Asterisk well-known primitives. And now I will give you one example of the protocol. So the extension 100 is calling 102. The end user app will send this here. He will say, I want to call number 102 using my device 1, which means my desk phone. Because we have also, in our own solution, we have integration with desk phone software, mobile devices, and so on. So let's forget about this. But then, when the call is started, an event simple like this is received. So no channels, no anything. It just says event call started, and the ID of this call is this. As you can see, this here, this is not a real unique ID of the Asterisk channel. It's what we abstracted for the user. Behind the scenes, there might be 5 channels, PJSIP channels. And it says, I don't know, the state of the call is ringing out, so that we can know if it's an incoming, outgoing call, and the call type, which will say, is it a regular two-way call, or is it a maybe conference call? So, and when the call is connected, as you can see, we will get again this ID here, and it will now mean that we can update on the screen and say that the call has been answered. And this is obviously information with whom we are talking to, 102, and this is the name. So now a real life example. I talk to my colleague, 102. I want to add some PSTN phone number into my existing call. So how do I do it? Very simple, like this. I will say, add into my call with this ID here, these phone numbers here, and eventually these calls, because in our solution we also have possibility to join other calls into my existing calls. So very straightforward API. And what we get is that now that the conference has been started with this ID, and this is our call, abstracted call that says now this call with this ID has been updated, and the call type, as you can see, have changed. So from a regular two-way call, we have just jumped into some conference, right? And the conference ID in this case is here. Now there is no connected number and name, because now it's not a regular call. Because of this C type here is to conference call, we now get this field here, which is new, and says we are now jumped into the conference with this ID. And then the standard asterisk conference join events, so that we can update on the screen other participants who joined into the conference of which we are part. So really straightforward API. And now to hang up the call, we just send the ID and that's it. So this means maybe somebody is calling us. My 5 devices are ringing. When I send this command here, hang up the call, it will actually drop all of them. It knows behind the scenes which are the channels to be hanged up. And the standard left, conference left, and now at the end, as you can see, we can get the event call finished, that the call with this ID here have just finished. Simple as that. And now let's talk about background jobs. So as we saw earlier, we added a person into the call, or maybe 10 numbers. We invite 10 phone numbers into the call. So in the background, that request will create actually the jobs, some background, I call it a background job. So for example, job 1 will be that we are inviting this number 1, 2, 3, 4 into the call. Job number 2 is the second user, and so on. So when you add somebody on your desktop, let's say into a call, it's not just enough to send a command and wait until the user appears. Requirement is obviously to know the progress of that invitation. If I invited somebody, I want to know, is he really ringing? Is the system calling him? Is he ringing? Has he answered the phone? And so the progress basically. So that's why I created the API to monitor background jobs progress and to display that on the screen, so that the end user can actually know what's going on with that channel, or maybe even cancel that invitation, because maybe we have by mistake entered wrong phone number to call and we want to cancel that. So API is like this. We get that after sending this request, we would get these, as you can see, initially that asynchronous request started with this ID here. So every job has its ID and has some type. So what is it? Is it about a conference invitation, or is it an originate, or whatever, so that user can track. And in the first one, we see that Asterisk is trying to call that person. In the next one, we will see that the person is now ringing. Then it's connected because the user answered, but it's still not joined the conference. And the completed means that the job really completed. So I invited person A into the call, he got the call, he answered the call, he joined the conference, job is finished, obviously. So we get the completed event. And then, of course, the standard asterisk event that says that the user joined the conference. And as I mentioned earlier, what if we, by mistake, enter wrong phone number? We want to cancel it before the user actually answers his phone. And we can do it like this. Just by sending the ID, in the background, system knows what is the channel to be hanged up, and so on. And as we can see, that we just cancel this one, and we get that the request, that job actually completed. And now let me mention about the multi-tenancy, how we solve that. So in the backend, we use configuration files and for queues, extensions, and all that stuff with a prefix of the tenant. But then this Unified Communications Gateway translates that, removes all the prefixes. So basically, user application, when it connects to the PBXware UC gateway here, it really doesn't know where it is connecting. It doesn't know if it is connecting to a tenant or to a standalone PBX. So for the end user application, everything is really transparent. In the backend, this one here does all the translations in and out. And I would like now to show you one simple example and the comparison. So when I was doing this presentation, I made a simple call from A to B using originate command. So click to dial example. And I created a comparison where this is how output from this gateway looks like. So JSON, very straightforward JSON events, like you see call started here, for example, call started. This background request, background job completed, and the call connected. Okay, and then I pressed hang up on the computer. So that's 3 events, as you can see. Let's forget about the hints, because it's just showing that it's just forwarding events from Asterisk. But let's focus on this here. So it's finished, it's connected, and started. 3 events. And in turn, and sorry, because of this. So now this is the output for that same call. That, I repeat, this system was really not busy. It's a test system where nothing is going on, just this single call. So this is the output that I got from manager. You can see this here. It's really moving slowly. And as you can see, tons and tons of events, all different kinds of events, bridges, channels, local channels, SIP channels, etc. So a really large file, a really complex file for such a simple call. That's, and all looks like this. This here is just enough information for a desktop, mobile, web application to display that the call has been started, answered, whatever. So that's the whole idea. Where did it go? And that would be it. Thank you very much. Time for questions. Like 6 months to a year, but of course I was not just focused on this topic. In my company I have other roles as well, so this is part of it. But this really came after, as I said, 9 years of experience with Asterisk Manager. I mean, I'm working on this unified communications application, which obviously is not just about Asterisk. It also has other services within it, like SMS, screen sharing, chat, which doesn't have anything to do with Asterisk. But the very big part of it is also depends on Asterisk, about conferencing, sending faxes, So all those audio stuff, phone stuff, depends on Asterisk. And after 9 years, I realized that it's so complex, really. I mean, the API that manager provides is just not that. For an end user application, it's too complex and too many stuff going in. We needed something simple, not just for us, but also for our partners. They want to integrate their CRM software or whatever with their phone system. So these guys really need something very simple. They don't want to lose months and years debugging, learning what is a channel, what is a bridge, how does actually manager work, because in fact you need to know how Asterisk itself works to understand all those backend primitives with which Asterisk works to actually do something. With our protocol, he doesn't need to do. End users, customers do not need to know anything about what is a channel, what is PJSIP, what is a bridge, etc. So we provided a really straightforward API for them, and that will allow us, our solution, to be more integrated into third-party software, which is today a requirement. Having a phone system today requires it to be connected to CRM and anything else. Any other questions? Seems like I did a good job for the first time. Thank you very much, guys.